crazy. Let's say you have a set X, Y, Z, right? And you take the power set. And what's the power set? The power set is a set of all subsets. So this is the power set, you know. Taking all the subsets. Right, that's the power set. This set has 3 elements, right? So n equals 3. Right. And how big is this power set? We got 1, 2, 3, 4, 5, 6, 8. So for a set of n equals 3, the size of the set is 8. Right. Decided to ask another question of myself. Let's see. Let's say you have a set of n elements. How big is the power set of n elements? Well, what you could do is, let's just try it out. Fuck it, let's try it. We got A1, A2, A3, A4, A5. Let's just do it for n equals 5 here. Alright, so first off, let's just list all the subsets of this set. We got this guy. We got each one of these guys. We also got each pair that's unique, right? So you got this. Oops, shit, forgot this one. Yeah. And then you gotta do that for each different pair, so I have to keep writing. But you get the idea. Basically, look at the way I started doing this. I kind of like isolated them into, I kind of partitioned all the subsets by how big they are. How many elements are in each subset. So this is the group of subsets with 0 elements. This is the group of subsets with 1 element. This is the group of subsets with 2 elements. And then there's going to be a group with 3, 4, and then finally 5. Right? So what we're doing is partitioning by the size of each subset. So that kind of gives us a way to count how many subsets there are. There's always going to be one where it's empty, and for the subsets of only size 1, there's just going to be n, the same number in the original set, in which case n equals 5 for this example. For subsets of size 2, how many are there? Well, you're picking 2 elements uniquely from 5, so it's really just 5 choose 2, or n choose 2, or whatever. So you can kind of deduce a general pattern, which is that the size of the subset is k equals 0 if your set has n elements. You're summing over the binomial coefficients. That's pretty cool, right? That's basically equal to n factorial n minus k factorial summing over all k. Tight, right? Well, and I went on Wikipedia, and it turns out they give you the answer. And the answer is that if you have a set of n elements, the size of the power set is 2 to the n. Wait a minute, what? What the fuck is that? Because I got this as my answer. But then I went to Wolfram Alpha, and it turns out that 2 to the n is actually equal to this exact sum. That's fucking ridiculous. This exact sum. Type it in yourself. Just go to Wolfram Alpha and verify it. It's nuts. And here's a cool way to demonstrate that. You know that. There's a quick way of getting the binomial coefficients, right? Just write this triangle right here. Sierpinski's triangle, or no, shit, Pascal's triangle. I don't even know what it's called. Fuck it, I don't remember. It's the triangle thing with the numbers, right? You just keep adding the numbers above to get the numbers below, right? So to get 0, choose 0, that's 1, right? To get 1, choose 0, that gives you 1, and 1, choose 1, that gives you 1. To get 2, choose 0, that gives you 1. 2, choose 1, that gives you 2. And 2, choose 2, that gives you 1 again. So yeah, that's basically, it's the same fucking thing. It's the triangle thingy. So to get n choose k, you just gotta look it up in this triangle. Well, what if you summed over every coefficient? Sum over 1, that gives you 1. Sum over 2, that gives you 2. 1 plus 2 plus 1 is 4. 1 plus 3 plus 3 plus 1 is 8. 1 plus 4 plus 6 plus 4 plus 1 gives you 16. 1 plus 5 plus 10 plus 10 plus 5 plus 1. That gives you 32. What the balls is happening here? Basically what we're showing is the fact that, I'll just show it here, whatever. This equals that. It's just too nuts, man. I don't know. Yeah, this video sucks balls, but it's also 4 o'clock in the morning. So fuck you.